Hello world, it's me. The reverse schematic for this Pro-Log PLS-881 single board computer is complete. I had a couple of hours free yesterday and I was able to finish the little details on this, the last few chips, and figuring out what the last chips were. Yes, this reverse engineering schematic does not look like a conventional reference schematic because I'm only interested in the net connections, but it is finished and it contains all the required information to completely characterize this board. After I get the board running and everything on this schematic is confirmed, I can take the schematic then forward to a final schematic and it's more a conventional form with wired connections and buses and so forth. Similar to putting an old puzzle together, there's always the worry that the last piece or two may be missing. In this case, the worry was that the last chips may have been something that was too exotic or something like a PAL or a GAL or a custom IC that would make this whole effort fail. Fortunately, that was not the case and I was able to finish the project with just some good old straightforward trace chasing with an ohm meter. Pretty much everything that I discussed in the last two videos came to pass, and in retrospect, the biggest difference between my original plan and how it all played out was that I had not intended on finishing the entire schematic before just firing up the processor and putting in the ROM and getting a serial port so I could communicate with my software. So I was just going to focus on the top part of the board, but then as some of the signals for the bus drivers and the status latch started to venture down in the lower part of the board, I had to do more and more of the lower part of the board. And in the end, I placed an order for some parts that I didn't have, and just while waiting for those parts, it only took another hour or two to just completely finish the schematic. So I went ahead and finished the schematic first, and that wasn't my intention, but I'm glad that now the schematic is completely done. Taking up where the last video left off, when I had some of this down here that I had to finish up, the output latches turned out to be just the same 74-175 that was used in the status latch. So there's nothing exotic about the output latches. The input ports, so these two guys down here, were the 7234 multiplexer. Remember, this is the one that we could see on that advertisement, that we could read the number off it, so we didn't actually have to figure out that this was the 7234 or the 8234. I actually just had to confirm that that chip fit the actual layout of the board. And then these two bus interface chips right here that I was thinking was 8T series, I able to confirm that, yeah, those are the 8T 28s. And you remember the other board, the 8821, had the 8T26s on its bus interface, so it wasn't a big stretch to go to the 8T28 for these guys. Finally, the last chip that I didn't have before was U10. U10 turned out indeed to be the port decoder, and it's just a simple 74-155. Now the 74-155 is quite literally a textbook decoder, and it's a very interesting chip, and it's the perfect device for port selection. Coincidentally, I was just recommending this book to somebody the other day, and I noticed that it spends a couple of pages, maybe 3 pages, on the 74-155 as a dual 1 of 4 or as a single 1 of 8 decoder. In its dual 1 of 4 configuration, the two decoders share the two select input lines. So it's a perfect fit for decoding memory or input and output ports that share addresses. And in this case, one half of the decoder is being used for the input ports and one half of the decoder is being used for the output ports. Since we're inputting and outputting to the same port addresses, these two select lines are just common to both the input and the output port. But each half of these decoders has its own enable strobes. So you can see these coming in, pins 1 and 2, 14 and 15. Those are the enable strobes for each half. So while both decoders share the common selects, they have separate enables. And on this PLS-881, the latches for the output port writes just enable this half, and the input port enables this half. So in situations like this board where we're decoding overlapping output and input ports, this is a perfect chip for that. Interesting, the 74-155 can also be operated as a 1 of 8 decoder simply by connecting the corresponding enables together. So you can see that on this half the enable is inverted and in this half it isn't. So if you connect those two together, that can be used as the third select input. So you can have A0 and A1 on the two primary select inputs. Then those that are connected together you can have as A2 or the third select, making this a 1 of 8 decoder. Then the other two are connected together, and that's your strobe for when you want these outputs to be enabled. So this is an interesting chip that can be operated as this dual 1 of 4, or it can be operated as a single 1 of 8 decoder. So the next time you're doing a vintage board design and you want to give it that little extra panache, think about utilizing the 74-155. So back to this PLS-881. When I was working on this, I was aware, I could just see that there was a little bit of corrosion on this inverter. This is where that 4049 inverter goes, and we can look at it here under the microscope, and we can see the corrosion on that socket. Now, a few of the other sockets showed a little bit of corrosion, but nothing was as bad as that one 4049 socket. And I didn't realize how bad the corrosion was over the entire board until I put the 8080 in. So that was the first chip that I put in. Started putting the 8080 in, and there was that definite, that crunch that you get when you're putting a chip into a corroded socket. So it was really crunchy as it was breaking open each of these. And so I decided, well, I need to replace some of these sockets. So I started prying that chip back out, and it was a beast to get that 8080 back out again. So I realize now how they happened to tear the pin off of this one that was down here in this corner, because once you put something in these, they were so corroded they were latching onto the pins. And I wonder what happened to this board, if it was exposed to something during its lifetime that corroded it, or maybe if it wasn't rinsed thoroughly during fabrication, or how those tin sockets came to be so corroded while the rest of the board is in like new condition. I'm not sure before I got this if this had even been inserted into a backplane. These fingers looked pristine. Rather than continually fight corroded sockets and the reliability and so forth, I decided to just go ahead and turn this into a little bit of a rework project and replace all of the sockets. So I took some time this morning and desoldered all of these sockets. So we can see that all of the sockets now, the solder's been pumped out, and a lot of these are very loose. Some of them will just fall out, and I think some others, they're loose enough I can just pull them out, or I'll just touch the back with either the soldering iron or the hot air gun and get the rest of them to fall out. And while this wasn't a step that I was expecting to do, it'll be a good opportunity to photograph the component side of the board without all these little traces that were hiding underneath before. When on the schematic, I was pretty sure that some of these were not connected. It'll be easy now to go in and look and make sure that either on the component side or the solder side, some of these pins are in fact not connected. So it's not something I wanted to do originally, but I think it'll be worth doing now that I'll have reliable sockets everywhere, and I'll also be able to get good photographs and be absolutely positive when I say a pin is not connected. So I'm off to finish removing these sockets and to see if that exposes any additional corrosion. Then I'm going to clean the board, photograph it, mount new sockets, and then finally I'll be back to where I was, or at least I thought I was earlier this morning when I started putting components in. Then finally we can see how the startup goes. So I'll be back to you when I am starting up the board, but I wanted to give you a quick update on where this thing is sitting. And that's it. I appreciate you watching. I will talk with you later. Bye-bye.